All right, we're gonna do another question for today. Here it is. Let's read it out. Given a sorted array of n integers that has been rotated an unknown number of times, write code to find an element in the array. You may assume that the array was originally sorted in increasing order. All right, so I underlined these key words here because this is going to tell me what my inputs are. Okay, so let's start out with the input. What am I going to be given? So it says I'm going to be given a sorted array, and I can assume that it was already in an increasing order. So if it was like this, starting off, and then it was rotated an unknown number of times, what rotation means is like if I wanted to shift everything to the left one, it would look like this. We would shift all these guys down one index and then shift one to the back. So now it's been rotated one time. Okay, so it's rotated. Cool. Now what are we doing? We are going to find an element. So that's one input. Our second input is going to be some number. Let's say that number is 1. Looking for 1. All right, cool. Let's figure out how to get to there. Okay, so we need to think about, we need to ask ourselves a few questions here. First off, how do we want to solve this? Well, since it's originally was sorted, that tells me, since it was originally sorted and I'm looking for something, I immediately think of using binary search. You use binary search on sorted stuff, or you're looking for something, so let's do that. So we're going to try to do this using a modified binary search. Okay, and that is going to be in O log n time complexity. And the space for this problem, it should be in O1 because we are not going to be storing anything. It's all going to be constant. Okay, so with binary search, we usually have a low and a high, and we think about, we look at different sections of the array, look at this section, ignore one side, focus on the other. So for this is going to be a little bit trickier because it's technically out of order by 1. So what we have to do is ask a couple questions to gauge where 1 is in relation to the array. So the first question we want to ask is the target, is the first guy, the 0th item here, is the 0th item greater than or equal to the middle guy, the middle item. Middle item. Why is that significant? Because if this is true, this tells me, okay, this is correct ascending order. This tells me that this is at least the correct ascending order, at least for this subset. So we ask that, and if that's true, we're going to ask another question. We're going to ask, okay, is the target greater than or equal to 0th item? And, big old and here, and is the target, is it less than? Is it less than the middle item? Because we ask this because we're trying to narrow our subset of the array. If the target is indeed greater than the 0th item, and it's less than the middle item, then we know that it must have to be in the lower bound where we'll do our search. So if it's in that lower bound, then that's where we focus on. So we would basically move we'll have two variables, by the way, a low and a high. Okay, I know this is a little jumbled up here, but stay with me. It makes sense. So you'll have a low, which usually always starts at the 0th. You'll have a high that starts at the array length minus 1. And we use these indices to tell us where we are at where we are narrowing our search in the array. So if this is correct, if this is true, if the target is in the lower bound, what we would do is set our high to be equal to where the mid is, minus 1. So then we would focus, what is this, 0, 1, 2, we would focus on this section here, if that were the case. If the number we were looking for wasn't 1. But in this case we are looking for 1. So it wouldn't be that case. It'd be the alternative case. Is 0th item greater? Is the 0th item? Did I put greater than? I meant smaller than. So if the 0th item is less than or equal to the middle item, we're in the correct order. But if this number was greater than 4, for example, then we'd have to ask a different set of questions. So if that means that stuff has been shifted around and maybe the biggest number is now at the front or something. Well, let's see. So if the 0th item is greater than the middle item, then we ask different questions. What questions do we ask? Well, we basically ask, is the target item greater than the middle item, which the middle is nothing more than the low plus the high divided by 2. Okay? Is the target greater than the middle? And we want to know something else about this. Is the target item less than, and is the target less than the high, or the last item, which is just where the where the high index is. So if the target is greater than the middle, and the target is less than the last item, then that tells us we're going to look at this upper bound over here. So we're going to ignore the lower half and look at the right half. So if that were the case, we would do some logic here. We would change our low to correspond to the mid plus 1. So now we shift our low from looking here up here. Let me turn off the sound so the beep for the timer doesn't go off and startle all of us. So if the target isn't greater than the middle, and the target is greater than the last item, then we want to focus our search to the lower bound. So in that case, so if this, do this, else, that's not true. We want to make our range from the 0th item to the mid minus 1. So then we say the high is going to be equal to the mid minus 1 down here. And that will lower the range down this way. And as we go along, changing out, doing the comparisons between the target and where we are in relation to the low element and the high element, we will begin to find where 1 is in this jambalaya of code. So this is a little messy here, so let me try to take what I wrote out here and actually make it into some like human readable code. Okay, so I'm going to take out, it's a lot I should take out here.
Take the top out.
Let me take out this top half. Right here. Okay. And I'm going to try to transcribe this. So if we're looking for 1, if our target's 1, what are we going to do? So we're going to have a low. We're going to set it equal to 0. Say let low, let high. It's going to be equal to the given input, which is an array, length minus 1. And then we're going to say let mid. Mid is going to be empty right now. We'll say while the low is less than or equal to high. This will be a break condition, because if low ends up being greater than high, then we know that we've looked through everything and we've exhausted all of our options and looked, and it doesn't exist. So let me take this out as well. And what are we going to say? We're going to say mid is going to be equal to low plus high. Since this is JavaScript, we have to math.floor. Low plus high divided by 2. That'll give us the mid. And then we'll ask, basically, if the array at the midpoint is truly equal to the target, this is something we need to ask every time, then we will return the item at that midpoint. I guess we can return the item, or we can return the index. Let's return the index. Let's return mid. Alright, I'm making a mess of myself. Okay, so we asked that initially. Does this middle item look like the target? If so, let's return the mid. Alright, but if it doesn't, and our example again is 2, 3, 4, 1, and we're looking for 1. It's our input, and output is 1. 1. Alright, so now we ask if the thing at the low, which is the 0th item starting out first, 2, if this number, is it less than or equal to the middle item? Well, middle item is 4, 2 is less than 4. Alright, that's correct. Okay, cool. We're in business. Alright, else? Okay. If all else fails, if we don't return a mid, we'll just return -1. There. So, alright, 2 is less than 4. So what's the next step we asked? We said if it's less than 4, we're going to now ask about the target. If the target is greater than or equal to the low item, which the target is not greater than 2, we're looking for 1, so that's not true, so that already fails that condition. But let's put in the other condition, the and. two ambersands signs, and we say, is the target less than the middle item? Because we're trying to pinpoint the lower bound. Is it less than that middle element? It is less than the middle element, but it isn't. But the target isn't greater than the lower item. Okay, so we have another else condition in here. Okay, this is going to get really tight in here. Let's see how I can do this. So if that, what are we doing inside of this if? If that's true, we're going to set our high to be equal to the mid minus 1. Else, if that's not true, so else, what do we want to do? We want to set the low to be equal to mid plus 1. So, because we've established that, all right, the target is not greater than 1 is not greater than 2. So let's make the low where the mid is now plus 1. So we make the low right here where the high is. So now it's going to be index 3. So low right here at this point is 3. Okay. So before we move on to our next iteration, we have to do our else statement right here for when the number at the low is actually greater than the middle point. So what do we say? So we say, okay, if that's the case, we're going to ask if the target is greater than middle, or the array at middle, and target is less than the array at the last position, so the last element in the array. If that's the case, then we basically want to say low equals mid plus 1. Else, we want to say high equals mid minus 1. So that is the full code. So if we're here in our step where we asked is 1 greater than 2, no, we go to this else condition. The lowest index becomes 3. The high right now is 3, right? So we're saying while 3 is equal to 3, it's still true. So we go down. We take 3 plus 3, which is 6, divided by 2. That gives us 3, which is our high and our low. We check, okay, is that item at that position, which is 1, is it equal, excuse me, right up here, is 1 equal to 1? It is. That's true. So then we return mid, which means we will return 3. And that is our answer. And that is how you solve this problem. And this is all done in O log n time with O1 space complexity. Thank you for watching. That's all.